Hello and welcome to the third episode in our BERT sentiment analysis on Vertex AI using TFX series. This time we're going to be talking about the pipeline definition. My name is Tomasz Maćkowiak and I work as an ML engineer at DLabs. Last two episodes we were talking about the motivations for even approaching the subject of MLOps. In the previous episode we were talking about how to create a model for text sentiment analysis. And this time we're going to be talking about how to create a pipeline, machine learning pipeline, that will be able to train and deploy such a model. First, we'll go over the steps on a conceptual level, and then we are going to see the definition in code. Finally, in the next episode, we will be talking about running this pipeline both locally and in the cloud. If you prefer to read instead of watching or listening, you can head straight to this link. This is the link to the full article that contains all the information about this subject, including links to our open source code of the pipeline definition, modeling code, and our open source TFX helper library. So let's build a pipeline for training our model. First, let's talk about it on the conceptual level. What should such a pipeline do? Well, first of all, we wanted to load a CSV dataset. Then we want to split this dataset into training, validation, and test sets. Then we want to generate data statistics for the imported dataset. We want to generate the schema of this dataset. We want to pre-process the data, so do all the feature engineering, label encoding, all this kind of steps. Then we want to tune hyperparameters for the model. That usually means creating few models with different hyperparameters and seeing which one performs the best, and then train a candidate model based on the best found set of hyperparameters. After we have trained the model, we want to find the previous blessed model to use as a baseline for comparison. We want to evaluate our candidate model, and we want to bless this candidate model only if it exceeds some static set of metrics, as well as if it improves over the baseline. This is a big thing, that's why it's in bold. It is rather easy to implement exceeding a metric, but it's not so easy to implement this check that the model needs to improve over the previous model. Why is that? Because it's not as simple as checking the values of the metrics. That would be the easy solution. But what if we have a different data set that we use for testing now? That's not so simple. What we actually have to do is we need to load both models. We need to run the predictions on the new test data set, calculate the metrics, and then compare the metrics. And this is quite a complex procedure. And in TFX, we are able to execute this without writing a single line of code ourselves. Finally, if the model was blessed, then we want to push it to be an endpoint on Google Cloud Platform. So now let's see how such a pipeline can be defined in code using TFX. The pipeline is just a collection of components. So what we will be writing is just a set of components with their configurations, and the components are connected one to each other in such a way that output from one component becomes input to another component. We're going to see this in a second. Usually the pipeline definition is expressed as a function that is supposed to return a set of components. This function doesn't have to have any specific signature. This is totally up to us. But if you are using our TFX helper library, then you will definitely want the pipeline helper to be the first argument you get. This is going to be the utility that will help us to select the correct version of a component. If we'll be running in the cloud, it will select for us the cloud version of a component. If we'll be running locally, it will select the standard version of a component. For those components that have multiple versions, of course. And the rest of the parameters are totally up to you. Usually you will probably have there some path to the training dataset. You might configure there some expected thresholds for accuracy or other metrics, maybe the proportions of the training, validation and test splits, some other configuration as well. So let's start by defining our first component. And the first component is going to be CSV example gen. This is the component that ingests a CSV file and produces examples. We can provide an additional configuration that will tell it to split the data already into different splits. Here we are configuring train, validation and evaluation splits with different proportions. And TFX is gonna take care itself of deciding which example goes to which split and of generating the output files with multiple splits. The next component is statistics gen. This is going to compute statistics over our examples so that we can visually inspect them and find out if we are by any chance not somehow getting wrong data. Maybe we can spot some problems like large amounts of null values and so on. And you can see here that we see for the first time how the components are connected together. The input to the statistics gen example parameter is the output from the example gen component. And this is how we are connecting the components together in TFX. Outputs from one component become inputs to a different component. In the next step, we want to generate the schema of our data. We plug in the statistics generated in the previous step, and that should be enough. In our case, the dataset is super simple. We just have those two fields, the text of the review and the label. And TFX is going to generate a proper schema for us. It's going to figure out that the label is actually an enumeration, so we don't have to adjust the schema in any way. If we had such a need, then there's an import schema gen component that is able to import a customized schema that you customize by hand and usually keep together with your source code. In the next step, we are doing the pre-processing, and we are using the transform component for that. We are plugging in the examples that we read, we are plugging in the schema, and we are passing in a callback function. And this callback function here is expressed as an importable name. You can see that we are importing from models preprocessing a function called preprocessing function. This is what we saw implemented in the previous episode. We can also pass in the configuration of splits. We can say, for example, that the preprocessing should be fit on the train and validation splits, but should transform all three splits. You can see that we are providing the callback as an importable name. That means that this function needs to be importable within from TFX. We will be talking about how to package this code later on, but just a heads up, we will be using Docker and we'll be putting the code of the preprocessing function inside the image that is going to be containing the TFX distribution. In the next step, we can construct the tuner component, which is going to take care of finding the best set of hyperparameters, but let's skip along and concentrate more on the trainer. To construct a trainer, we are using our pipeline helper and we are calling construct trainer method. This is gonna select the appropriate version of the trainer component, either the GCP optimized one or the standard trainer, depending on which type of pipeline environment we are running in. Then we need to provide the callback for training, the run function, again as an importable name. We have defined this function in the previous episode. Then we are plugging in the transformed examples, the ones that are coming already from pre-processing. we are also plugging in the transform graph. So the code of the transform procedure. We are also plugging in the schema, the best hyperparameters from the tuner component. We can also define which splits the training and evaluation should work on. And so we are configuring that train split should be used for the training set and validation split should be used for evaluation set. And we can also provide a dictionary of custom configuration. If the trainer creates a model for us, we want to validate this model and we want to compare it with the previous best model. But to do that, first we need to actually fetch this previous best model, and we can use the resolver node for that. We are saying that we are looking for the latest best model, and it's going to find the previous model that passed the validation and was the best, because we will also be configuring the comparison in the evaluator component. And now we will be proceeding to configure the evaluation of the model, and we will be using the evaluator component to which we need to provide configuration. And this configuration consists of few parts. The first part is the definition of the model, how it should work, which signature to use, what is the key of the label in the data set, and so on. We can also configure slicing specs. If we configure slicing specs, we can configure it in such a way that during evaluation, the TFX evaluator is going to compute the statistics separately for slices of a dataset based on specific features. For example, if you had a gender feature in your dataset, you could configure here that you want the slicing spec to be on gender, and then all the metrics that are going to be computed over the possible values of the gender feature. So you would get, for example, an accuracy score for men and a separate accuracy score for women. In our example, we don't have anything to slice our dataset on because our dataset just has this one input feature that is the raw text. So we are configuring only the overall slicing spec, which means the whole dataset. And the last element of the configuration is the configuration of the metrics themselves. And we will be configuring binary accuracy, and we are only doing this in a declarative way. And this is a beautiful thing about TFX, that we are expressing all this as configuration, not implementation. Here we are defining that we are interested in binary accuracy to exceed a certain threshold, and we can also say with the change threshold argument, we can say that we are interested in the value of the metric being higher by a given epsilon than the previous baseline model. So very complex things that are going to be happening here, expressed as pure declaration, no implementation. It's a very big selling point of TFX for me. We are plugging this configuration to the evaluator component along with the baseline model that we found later, the trained model from the trainer component. We also plug in the examples and the splits that we want to run the evaluation on. And finally, we are configuring the pusher component, which is going to take care of pushing the model to an endpoint on Google Cloud Platform. Alternatively, if we are running locally, it's going to push it to a directory, and from this directory we could serve this model using a local TensorFlow serving instance, which we're going to do in the next episode. To this pusher component we are passing, of course, the model, the candidate model, and the model blessing from the evaluator component. If the model doesn't get a blessing, it's not going to be pushed, and this is a way of making sure that you never push to production a model that doesn't conform to the thresholds that, for example, accuracy thresholds that you set for it. Or you can also prevent a model that is worse than the previous model from being pushed. And once we define this pipeline like this, and we would upload it to Google Cloud Platform, this is how the pipeline would be visualized inside the Vertex AI pipelines interface. You can see that the components are connected between each other using the artifacts. For example, the tuner to trainer, there's an artifact that is connecting them. That will be the best set of hyperparameters artifact. And all the components, they are connecting in the same way, always through an artifact. And that's how TFX resolves the order in which the components are supposed to be running, and how it passes the artifacts between the components. So we managed to implement the pipeline. We managed to do it in purely declarative code. That means that we were, for most components, just saying what they should do, but we didn't have to specify how they should do it. The implementation mostly comes from TFX. We don't have to write our own code, only for those bits that require very custom logic, like the pre-processing logic, the training logic, and the hyperparameter tuning logic. Those are the only three components that require us to provide callbacks. You also noticed that because of using our TFX helper library, we didn't have to have any if statements. Our pipeline definition is very clean. We don't have to select which version of the component we want to choose. The helper takes care of choosing that for us. So that was the third episode. We presented how to define a machine learning pipeline, end-to-end pipeline. In the next episode, we're going to be talking about how to run this pipeline both locally and in the cloud. As always, you can head on to the full article text under this link, where you will find all the information from this series of videos and more, and also links to the open source code of the pipeline definition, modeling code, and our TFX helper library. Thank you.